Hi grade 8s, this is Mr. Tosarski. Welcome to your first digital lesson. I'll keep posting weekly up onto this YouTube channel here, so if you want to subscribe to make it easier, but of course I'll always have links to the appropriate videos in D2L. I am recording this inside of the school, so from time to time you will hear announcements come over the PA, and I will do my best to mute my mic so that we don't hear that or edit them out, but sometimes I can't go fast enough. The other thing is I have this lovely smart TV, and so you will hear my pen tapping on the glass like that, so just pretend that you're listening to that wonderful sound sitting in the desk in the classroom. So we're going to start off. Our first unit that we're going to have is ratio, rate, and proportions. So today I'm going to talk to you about ratios. So a ratio is a comparison between things that are the same type or unit. So they have to be the same type of thing. Okay, so I can compare, if we're looking at these little circles here, we'll call them marbles. So I've got red marbles and I've got blue marbles, and because they are both the same type of thing, I can compare them in a ratio. So the way we generally write a ratio is I might want to compare the number of red marbles to the number of blue marbles. And so if I want to do that, I have to write the number of red marbles first, which is 3. And then the number of blue marbles after, which is 2, and those numbers are going to be separated by a colon, okay? And the way we read that is 3, 2, 2, all right? And so the colon in between is really the word 2. All right, so that's how we say that as we read it out loud. Now I wrote 3 and then the 2 because the ratio was asked red to blue, so I have to follow the same order as it's written. I can write a different ratio, which would be blue to red, and this ratio is going to be different. I would write it as 2 to 3, okay? It is a different ratio because the order has switched around. So the order that it is written is the order that the numbers need to go in, okay? What we call this type of ratio is what we call a part-to-part ratio. And it's a part-to-part ratio because each value that I'm looking at, so each number, represents only a small portion or part of the larger grouping. So if we think about these marbles, this is all of the marbles that we have, and we are comparing two smaller groupings within that large group of marbles. Okay? We also have something called a part-to-whole ratio. A part-to-whole ratio compares part of the group, so a small part of the group, to everything in the group. Okay? So what I could do is I could compare the number of red marbles to the total. All right, if I compare the number of red marbles to the total number, there were 3 red marbles and 2 blue marbles. So in total, I had 5 marbles. So I could write that as 3 to 5. Now often, when we have a part-to-whole ratio, we end up writing that as a fraction. And that kind of makes sense because it's 3 out of our 5 marbles were red. Okay, so if I have a part-to-whole ratio, I can often write that as a fraction. All right. So here we go, I've got some shapes here. So I can compare these two shapes together because they fall under the same category of shapes. Now I know they are different shapes, so I can compare the smaller grouping to itself, right? So I could compare the number of squares to the number of triangles. And if you can count them here, we have 2 squares compared to 4 triangles. Okay, but what I want to do is I want to find an equivalent ratio to this 2 to 4 ratio. And the way I want to keep it equivalent is I need to make sure I have the same proportion. So what this ratio tells me is every time I have 2 squares, I need to also have 4 triangles to keep that same proportion. So if I was to take these 2 squares and draw them again, I need to also take 4 triangles and add them again. I need to make sure that I have the same proportion. So every time I add 2 squares, I must also add 4 triangles. And now if I look at this larger grouping altogether, I have 4 squares to 8 triangles. And that is what we would call an equivalent ratio. I have kept the proportion between these things the same. Okay, I drew 2 more squares and made sure to add 4 more triangles because that was my original ratio. Now, you probably don't want to redraw these things every single time, and so a faster way of us doing that is I could say to go from 2 to 4, I multiplied by 2. And to find the other side, I have to multiply by the same value. So I can find an equivalent ratio simply by multiplying both parts of my ratio by the same value. Okay, so that would give me an equivalent ratio. Now, with this ratio that we had, I'm going to draw these squares and triangles again, put them down here. Okay, if I had the squares and the triangles here, and we had our ratio being 2 to 4, there's something else that I can do with this to still have an equivalent ratio. Because what I could do is I could split these squares into 2 separate parts, and then I can split the triangles into 2 separate groups or parts. And now what I've done is I've taken this, I still have the same number of squares and triangles, but I've split them into 2 separate groups, where each group has 1 square and 2 triangles. Okay, so if I'm splitting it into 2 different groups, what I'm really doing is dividing by 2. And I'm allowed to divide both values in that ratio by 2. That works. 2 divided by 2 is 1, 4 divided by 2 is 2, and so I have another equivalent ratio of 1 to 2. And this one, what we would call here, is our ratio is in lowest terms or simplest form. I like to use the word lowest terms, so you're going to hear me say that a lot. We've put that ratio into lowest terms, and what that means is if I was to try to divide a 1 or a 2 by the same thing, one of them would end up being a decimal. And that is bad. I don't want any decimals in my ratios. I want whole numbers only. Okay, so if I have those values 1 and 2, I could say, yes, I can divide 2 by 2 and get 1. But if I do the same thing here, and you type in your calculator 1 divided by 2, and you get 0.5, we do not want that in our ratios. We want whole numbers only. So it doesn't work. And you could pick any other number, you're always going to get a decimal. Okay? So, similar to what you would have done in grade 7 with fractions, you are going to be putting ratios into lowest terms. And that is what's called an equivalent ratio as well. Okay, so to get equivalent ratios, if we think back to the beginning, I said equivalent ratios, we can get them by either multiplying or dividing all values in the ratio by the same factor. Okay. Now, I could have picked anything for my earlier equivalent ratio, so let's work with this one. What if I have the ratio 6 to 4? Can you find 3 equivalent ratios? And if you want, you can pause for a minute so that you can think of finding some equivalent ratios, and we'll see if I can guess the ones that you got. So take a second to pause the video, come up with 3 equivalent ratios. Okay, great. I'm sure that all of you paused it because you follow directions so well. So if I have this ratio 6 to 4, what I could do is I could divide both values in my ratio by 2, and I could get a new ratio 3 to 2. That would be an equivalent ratio. I could also multiply both values in my ratio by 2, and that's going to give me 12 to 8. That is an equivalent ratio. I could also have taken 6 to 4 and multiplied both values by 10. just because it's easy to multiply by 10. And I have 60 to 40. That's an equivalent ratio. And I also could have taken this equivalent ratio 3 to 2, and I could have multiplied both of them by 3 and gotten 9 to 6. That's an equivalent ratio. And you can probably see here that I've picked all sorts of different things. I divided by 2, I multiplied by 2, I multiplied by 10. I could have multiplied by 5 or 6 or 7 or 8 or 9 or 1,000, or I can really come up with as many equivalent ratios as I want. Now, there is only one way to get down to lowest terms. This first one that I gave you is that equivalent ratio in lowest terms, but there are lots of different things I can multiply by. Okay, so that's your quick rundown on ratios. You're comparing two things that are of the same type of thing. Order matters, so pay attention to the order it's written down. Find equivalent ratios by either multiplying both numbers by the same thing or dividing both numbers by the same thing. And when you're doing the division, no decimals. Okay, if you've divided all common factors, it is what we call lowest terms. All right, there's your ratios.